Welcome everybody. Today I wanted to show you a short example how to deal with missing values. Let's get right into it. A short preview of the content we're going to go through today. We're going to start with using a wind turbine dataset containing real data for 2.5 years. The reason I picked up this dataset is because it is a challenging dataset to visualize in one place of where we have missing values and particularly periods of missing values, and be able to understand how many of them are available for each feature in the dataset. To tackle this, we're going to use a library in Python called msno. It is a very powerful visualization library. And after I show you this, I'm going to show you a few basic techniques which you can use to fill up the missing periods of data. Let's get into the code. For demonstrations, we're going to use Google Colab. First, we start by uploading the libraries. You can see the libraries here. Then we're going to load the data. This is the turbine dataset we talked about. And every time when you use data, you can run the .describe function in pandas, which is a very helpful way to start any kind of data analytics. You can see that this .describe function tells us that it gives us very helpful parameters to gauge the data on, like particularly count of values. We have the mean values for each feature, each column in the dataset, standard deviation, minimum values, some percentile figures, and the maximum values you have in each column. If we move forward, we can see the .info function. The .info function will display us the column names. We can see we have a total of 22 columns here. There is just over 100,000 values in total for each column. Now, the pandas library is very helpful visualizing the dataset, but what I found is that if you use the msno library, you can visualize very quickly any missing periods of the data. Let me show you. You can see the whole dataset with the periods of missing data. You can see we have the unnamed column, which is essentially the index column, which is absolutely like with very good data completeness. But we have other features in the dataset which have periodically some missing chunks of data. And you can see here we also have periods of the data where we have absolute absence of some values. This is for more than half of the dataset for in particular these three features. On the right side, you can see that we have statistic showing the number of columns available, the number of features, data completeness available. And in the beginning, we have partial data, but when we get to the bottom, to the last periods of the time frame, we have consistently better data completeness. This library is used not only for visualizing numerical data, but it can be used also for categorical data. Now, the next function from the same library will show us some bars. It will display the number of available values overall for each feature. You can see it displays it in percentage on the left side, and on the right side it shows the absolute values of each one of the features. Now let me show you how you can dig into each missing chunk of data. This function I prepared here plots a line of the active power feature from dataset. What this chart shows you now, there's a cyclical behavior of dataset, and if you use imputation from other periods of this data, of this data feature, you will likely have bias, and any fill-up methods you feel will likely add more bias, and it will be very difficult to work with this data. Let me visualize to a particular moment to show you. Here we have periods of absolute missing chunk of data, and here we have a period where we have zero value. So as you may imagine, some of these will have to get cleaned up if someone was to work with this data. What we have next is we're going to use the isna function to see how many missing values we have for the active power feature. When you load it, it will tell you that we have 23,000 missing values out of the 100,000 plus values. Okay, and this was the first part of the video. And now I'm going to show you how you can impute some of the data that you have missing. Now, why we want to use filling methods for any missing data in our datasets? It is simple. It is because we want our models to be able to converge and produce high quality output data. Most machine learning models will not like ingesting non-available data. They wouldn't know what to do with that. Therefore, we need to fill it in. And also to produce good signal quality, essentially good output, we need to have very good quality input. For this purpose, we're going to use the following dataset. For the imputation example, we're going to use this simple dataset, and I'll show you what it looks like right now using the visualization technique before. The first technique I wanted to show you is the fill forward technique. The first function I want to show you is the fill forward function. When you use that function, you can see that the values that were in the previous timestamp are carried forward. But if you have values in the beginning, the 0th index value that is missing is not going to be filled up. Also, when you're using this function, you should ensure that you understand what limit you have set up. Because if you set up only limit is equal to 1, then this means only the next step is going to be filled up. And if there's 2 or 3 steps or longer periods of missing data, these will remain empty. The next technique is the fill backward technique. It's essentially the reverse of the fill forward technique, and you can see that all the values from the future are repeated back into the past. The next function is the linear interpolation function. You can see when you have numerical missing values, the average number is taken. Here, for example, we have the first index being equal to 100 and the third index 200. We're taking the 151 as a value in between. And the last one I wanted to show is the rolling mean function, which is tricky because it overrides some of the available values you had previously, and the overall visualization of all the filling methods, which we walk through here. If you found this video helpful, please consider liking, subscribing, and also commenting anything you want to see in the future. Thank you.